In this third lecture module, I want to go over a few permutations of a categorical syllogism, and then in the fourth and final lecture module, we'll go over reconstructing the logical form of a categorical syllogism from its mood and figure, and then evaluating that logical form for Boolean and Aristotelian validity using our Venn diagram effective decision procedure. Let's start. All compounds that destroy the ozone layer are environmental hazards. All chlorofluorocarbons are compounds that destroy the ozone layer. Therefore, all chlorofluorocarbons are environmental hazards. Now, you might want to stop the video. As always, try and complete the premise and conclusion diagram, determine whether or not you think the argument is valid in Boolean and Aristotelian logic, then start the video and compare what you did to what I did. As always, we start by drawing a premise diagram and labeling it, drawing a conclusion diagram and labeling it. The minor term, the subject of the conclusion, goes on the bottom left. The major term, the predicate of the conclusion, goes on the bottom right. The middle or bridging term, the one that's in both premises, goes up top. Once I've drawn and labeled my diagrams, I'm free to start entering information into them from the premises or conclusion. I'm going to start with the premises. Since both of the premises are universal, I can do either one. I'm going to go ahead and do the first one first. All compounds that destroy the ozone layer are environmental hazards. All D are E. Now, I'm going to be a good Boolean because I always start off in Boolean and I say I don't know if there are any D's and I don't know if there are any E's. But what I do know is if there are any D's, then those D's would have to be in E. Therefore, the areas in D outside of E would have to be empty so that this standard form categorical statement could be true. So I shade those areas, indicating that they have to be empty, and that is what minimally would have to be true under the Boolean interpretation for this universal affirmative statement to be true. I move to my next one. All chlorofluorocarbons are compounds that destroy the ozone layer. Again, I'm being a good Boolean, and so I say, look, I don't know if there are any C's, and I don't know if there are any D's. But what I do know is, if there are any C's, they would have to be in the D area. So the area of C that is outside of D would have to be empty if this premise is in fact true. So I shade those areas, all the areas in C outside of D, and now I've satisfied what minimally has to be true under the Boolean interpretation for that universal affirmative premise to be true. Time to go over to my conclusion diagram. My conclusion says all chlorofluorocarbons are environmental hazards. Again, I'm being a good Boolean, so I say, look, I don't know if there are any C's, and I don't know if there are any E's. But what I do know is, if that conclusion is true, then at minimum, everything that is in C has to be in E, if there is anything. And so, all the areas of C outside of E would have to be empty. So I'll shade those areas. At this point, I need to evaluate this argument for Boolean validity. So I look at my conclusion diagram, and my conclusion diagram says I need the areas outside of E in C to be empty, guaranteed, in order to guarantee that this conclusion is true. I look over at my premise diagram, and if the premises are true, both of those areas that are in C but outside of E are in fact guaranteed to be empty in making those two premises true. Therefore, if the premises are true, the conclusion has to be true as well. And so this argument is valid in Boolean logic, and because it's valid in Boolean logic, it's also valid in Aristotelian logic. Let's look at a different permutation on this same argument. Let's suppose that our conclusion is different now. Our conclusion is no chlorofluorocarbons are environmental hazards. I filled out my Venn diagram under the Boolean interpretation for my premises, just as I did before. Now I turn to my conclusion diagram, and my conclusion says no chlorofluorocarbons are environmental hazards. I'm being a good Boolean, so I say, look, I don't know if there are any C's, don't know if there are any E's, but what I do know is whether or not there are C's and E's, there can't be anything that is both a C and an E. Therefore, that intersection between C and E, both areas that are in the C circle and the E circle, they would have to be empty. So I'll shade those in, and that will guarantee that the conclusion is true. Now I need to evaluate my argument for Boolean validity. I look at my conclusion, and it says there can't be anything that is both a C and an E. That area has to be completely empty. I look over at my premise diagram. If my premises are true, well, the bottom half of that intersection is guaranteed to be empty, but the top half there is no guarantee, and hence it's possible for my premises to be true without guaranteeing that my conclusion is true, and as a result, this argument is invalid in Boolean logic. So now I want to evaluate it for Aristotelian validity. I go over to my premise diagram and I look for any circles that have 3 of their 4 areas shaded. There's only one, and that would be the C circle, the chloropluorocarbon circle, the minor term. It's got 3 of its 4 areas shaded, so I can put a circled X in that C circle because I know exactly where it would go. So I put that circled X in there, and I now want to evaluate the argument for Aristotelian validity. I look at my conclusion. I still need that intersection between C and E to be completely empty. I look at my premise diagram. Under the Aristotelian interpretation, it's definitely not going to be empty. There'll be at least one thing that's in that intersection in the C circle, and hence this argument is invalid in Aristotelian as well. Let's look at one last permutation. Suppose that my conclusion now is some chlorofluorocarbons are environmental hazards. I fill out my premise diagram just as before. I turn to my conclusion diagram. Now my conclusion says some C are E. So I say, okay, there has to be at least one thing, call it X. It's inside my C circle. It is also inside my E circle. So it has to be in that intersection. Nothing about my conclusion says, and it's D, or it's definitely not D. So my conclusion doesn't care whether it's D or not D. So I put it on the line there to say my conclusion will be true if it's anywhere inside this area. So now I want to evaluate my argument for Boolean validity. I need a member of the C class that is also in the E class, something in that intersection between C and E, in order to guarantee the conclusion is true. I look over at what I get when the premises are true, and there aren't any X's at all in that diagram. So it's possible for the premises to be true without guaranteeing the conclusion is true. So this argument is invalid in Boolean logic. Now I want to evaluate it for Aristotelian logic. So again, I don't have to worry about my conclusion diagram. I just go to my premise diagram, and I only have to worry about those circles, those classes, where 3 of the 4 areas are shaded. There's only that one. C has 3 of its 4 areas shaded, so I can enter a circled X in there because I know exactly where it goes. I put it in, and now I want to evaluate the argument for Aristotelian validity. I look at my conclusion diagram, and it says the conclusion will be true if there's something that is both a C and an E, regardless of what else it is. I look over at my premise diagram, and it says under the Aristotelian interpretation, there is at least one thing. It is a C, it's also an E and a D. And so I'm formally valid under the Aristotelian interpretation. It's impossible for the premises to be true if the Aristotelian interpretation holds, and my conclusion not also be true. So now I want to evaluate whether or not that C class, the one I put the circled X in, has members. I look up at my argument, chlorofluorocarbons exist, therefore it's a perfectly good Aristotelian class, there's at least one member, and so this argument is valid in Aristotelian logic.